Welcome to this episode of How It's Made. Today, we're going to deep dive into how the array lists we talked about last time are made behind the scenes. Because of that, this video will be a bit more technical than the others, but I'll try to keep it entertaining. An array list is a resizable array represented as an object that implements the list interface. That part we already know, but how does it do that? Let's download the starter code below and get started. I've already provided the class header and some default methods that we want to support, and we also have a list interface that all of our other list data structures will use as a starting point. One new thing I want to call out is this weird T thing. It's called a generic. I'll go into more detail on what generics are later, but for now, just know that it means that any type can go into that spot, and Java will know, okay, this array list is a type of that type only. It's part of that parameterized topic I mentioned last time. Now we have our base API we need to implement. So let's get the underlying data structure together. Let's make a private internal array of our generic type called content. Now let's make a default constructor and do this.content equals t open close square brackets all in parentheses new object array of size 0. We can't directly build a generic, so we have to cast our object array to it, since generic is an extension of object. And it's 0 because it's empty to start. Now, let's implement our API surrounding this content array. So get I, add location I, etc. So we can interact with what we already have. Let's start easy. Size. Just return content.length. Next is empty. Call size, and if it equals 0, return true. Otherwise, return false. Get I. If is empty, or I greater than or equal to size, throw new exception. Otherwise, fetch the value from the content array like you normally would and return it. Now we see an error. This is because we need to throw the exception at our method level as well. So let's go ahead and update our get method here and in our interface to throws exception. Add gets a little bit more complicated because, well, we're at size 0, and even if we're at size 10, how do we know what spot we're at? So now we need to do a lot. Let's tackle these one at a time, shall we? Well, how can we know what the latest index is? Well, size works, right? Because we know what we're adding is going to be at the end, so size is 1 plus the largest index. And that's where we want to add our new value. Okay, now how do we do that when our add point is greater than our current size? Well, and this is going to sound weird, we just double the size of our array. Well, for non-zero size, because 0 times anything is still 0. That's an edge case which we do need to handle. So for size 0, let's just make it equal size 1, fill that slot, and then exit. So if size equals 0, this.content equals the t square brackets in parentheses new object array of size 1. Then this.content of 0 equals input, and then return, which will just exit immediately. Now we can assume all other additions will be on an array that has some existing content. So let's handle that case. Instead of just overwriting content like above, we need to be careful to not lose our current info. So let's create something called Temp that will act as a placeholder for our existing content. So t square brackets temp equals content. Now make a new object array just like above, but with the size of it being content.length times 2 instead of 1. Now we need to copy all of our old values over to the new one. So for int I equals 0, I less than temp.length, I plus plus, this.content of I equals temp of I. Then after all of that, we're going to add our newest value, this.content of temp.length equals input, and done. Now that we see what we're doing, I'll tell you why we double it every time. Each time you create a new array, it becomes increasingly more expensive to allocate more space, copy everything over, etc. So we decide to use the fact that memory is in multiple gigabytes these days to go, screw it, just double it so that we don't need to do this every time we add something. Okay, so how about add at location I with input? This one's a little more complicated. I can be any number, so we have to think about what happens if I is greater than the size of our list so far. Well, what would go between I and the current latest number? There's no real way to know, so instead, we need to throw an exception, pretty much saying this can't be done. And that means we need to throw an exception on the method here and in our list interface. And now what about when I is equal to the size? Well, that means it's going to be larger than the index because of our off by ones, so we need to increase the number of size and then add it to the end. So just like in our add, so we may as well just copy the method from above and change the I to a j because we've already used I in this method. And lastly, we need to turn temp.length into I because we're adding that I and not some other temp.length value. And now what about someplace in the middle? After we've already checked that it'll fit, otherwise we've doubled our space, what we can do is just move everything to the right until we hit that space. That way we don't need to track multiple things at once. We just move the end to 1 over, and then the one next to the end, back next to the end, and etc. So we're going to create a for loop from int j equals this dot size, then j greater than I, then j minus minus, which means we're going all the way from largest value down to our I value. Now in our loop, we're going to do this dot content of j equals this dot content of j minus 1. So we've shifted everything over up until I. Afterwards, now we're going to replace our I value. So this dot content of I equals our input. Okay, but what about this remove? Well, we can start at that point and shift everything left, the opposite of what we just did, overwriting the old value and then setting that last value to null. Instead of changing the last value, we modify to our input. How about contains or index of? Let's build index of first. So we'll loop through the array, checking if we find the value. If so, return the current I value, otherwise return -1 because it's not there. Contains, just call index of and convert the answer to true false. True if it's greater than -1 or false if it's -1. Add all, well, just loop through the new list and just use add. Let it do all the work for you. And that's all the operations that we're going to care about for now. But there is one last thing. Pause here and think about it for a second. What does array.length return? The space allocated, right? Not the highest index. Well, that means our size is wrong, which means we're adding to our array wrong, and allocating size wrong, and doing isEmpty wrong, and This is the trickiest part of the ArrayList data structure. Size needs to be tracked separately, but now that we have all of our methods implemented, we just need to properly interweave it into every method. So let's go through them. Set a variable private int index, then in our constructor, this.index equals 0. Now let's handle the easy ones. In add, we're going to do an index plus plus after we set the last value, which will be right before the return in the if statement or right before the method ends. We also need to include this increment index logic in our add at location method so that all of our add logic is accounted for. Well, what about remove? Well, we'll just do index minus minus right at the end. And what about size? Well, now that we know index is our size, just return the index. And now we're done, because all of our other methods use those methods. Now, if you compare this to the actual list and array list, you'll notice I missed a lot of methods. That's either because they're too complicated for where we're at now, like sort, or that I ran out of time to implement them, like sublist. If you want me to follow up on some of those other methods, just let me know below. Except sort. That's a whole series of algorithms to chat about. I also would not be surprised if my code has a bug or two in it, because there are a lot of edge cases to make sure it's robust and doesn't break on the user. This is why you need a really good reason to implement your own data structure if it's one of the common ones like lists or maps. Those have been perfected over decades and have already ironed out all of these edge cases. These videos are more to give you insight into what is happening and less about doing something exactly like in the real world. But I do provide some sample test code to show you that it does at least appear to work with a basic workflow. And congratulations, if you've been following along, you have now made your first data structure. Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.